So an investor facing an investment universe with a risk-free asset and a risky portfolio, and the constraint that they can put any amount of money in either of these assets and allocate any portion in either of these assets, can choose an asset allocation set along this line. The question is, where should they be along this line? So they can choose any point on the cal. All points are achievable. So how do we pick one? And so what we're going to do is we're going to select and plug it into our equation. So let's assume an investor wants a combined portfolio with a risk of 15%. This isn't really how it's going to work, but for now, we'll just assume that we're going to choose a risk and get a return because it's our x-axis versus our y-axis. So let's assume that an investor wanted a combined portfolio with a risk of 15%. So therefore, our notation is sigma c is equal to 15. What combined portfolio return corresponds to this risk? Well, I have this equation. I know that if I plug in 0.15% here, here is my universe, which is the risk-free and the risky. I'm going to plug in the 0.03 plus 0.15 times 0.1 minus 0.03 divided by 0.2, and I get 8.25%. And so that I know that an investor who is choosing a risk of 0.15 will have a return of 8.25, and they have allocated y equals 0.75. Remember, y is the percentage of the combined portfolio in the risky. And so I can scroll down, and now I have my graph. And I can see that this person has chosen this combined portfolio C, this green portfolio, based on this risk, this return, and I can see that I am 75% in the risky, 25% in the risk-free. So I'm 75% of the way along this line, 75% of the way up this line. So the question is this good? Is this a good combined portfolio C? And the way we're going to check this is we're going to see what utility this investor achieves by investing in this allocation. Now, of course, this depends on the investor's level of risk aversion. Remember, we have a utility function, which is a function of risk aversion and the risk and return of the combined portfolio. And so we're going to let A equal 2 for now. We're just going to define this investor as an investor with a risk aversion level of 2. And from this, we can compute the utility. And I can see that the utility from investing in this combined portfolio is, well, using my utility function, the return minus the risk aversion times half the variance, 8.25%, minus 2 times 0.15 squared over 2. And this investor has a utility of 6%, or 0.06, which corresponds to a certainty equivalent rate of 6%. What if instead the investor with A equals 2 wanted a risk of 8? So instead of having a risk of 15, they chose a risk of 8. And so they're going to be somewhere over here instead. Let's see what combined portfolio return corresponds to a risk of 8 and what is the utility. And so now I can plug in again, but instead of plugging in the value I plugged in before for the risk, 0.15, I plug in 0.08. And I see that this investor now has a return of 5.8%, which corresponds to 40% of their money in the risky asset. And so now I can see the utility, which was 0.006, is now 0.0516. And so here I am further over on this same cal. Both of these are achievable. Here was the first combined portfolio. Here's the second combined portfolio. And I can see that this combined portfolio, just to recap, an investor with A equals 2 has this investment universe. They can invest in the risky portfolio, which has 10% return and 20% risk, or the risk-free, which has a 3% return. The allocation set is a straight line called the capital allocation line, and the investor may select any combined portfolio C that lies on this cal. Note that these are the only opportunities available. The investor would love to invest up here, but they can't. This isn't available. They don't want to invest down here because note that anything that's on this line dominates it, but it doesn't matter. So remember that this ISO utility curve does not represent investment possibilities. Only the black line represents investment opportunities. This investment, if it were available, would be equivalent to C, And this investment, if it were available, would dominate P. And so since this spot on this curve is equivalent to C and dominates P, we can see that this dominates P. In addition, this spot would dominate this if it were available. It's not, but it's equivalent to this spot. And so therefore C dominates the risk-free. And I can see that every single spot on this iso-utility curve dominates every spot on the cal except where they intersect. And so the intersection of the iso-utility curve and the capital allocation line is the spot where they are investing. Okay, so the allocation set, so the investor has A equals 2, and this investment universe, which is an expected return of 10% and a risk of 20 for the risky and a risk-free of 3. The allocation set is a straight line called the capital allocation line. The investor may select any combined portfolio C on the cal. There are no other investment opportunities available. And so we think about the choice as selecting risk on the x-axis and computing the return on the y-axis and then computing the utility. And note that we could also compute the y. And so here's our two choices so far. We arbitrarily said, well, let's have y equal 0.75, which is equivalent to the risk being 15%. And we saw a utility of 0.06. And then here we saw that y is equal to 40%, which is equivalent to a risk of 8% and has a lower utility. And so for now, we can see that this allocation is better than this allocation because it has a higher utility. And I should have drawn these a little bit more parallel, the purple line and the green line, but they're close enough. And I can see that the green iso-utility line dominates the purple iso-utility line. I can also compute that this green allocation has higher utility, and so therefore this utility is better, this allocation is better than this allocation. So which of these two choices is better? The combined portfolio C with y equals 0.75, a return of 8.25, and a risk of 15 is better since it has the higher utility. So here's my next question. Which spot along this line, everything is achievable between R, F, and P, which of these is the best? Which will produce the maximum utility? In other words, what is the optimal combined portfolio? And we're going to define it as an optimal because it maximizes utility. And so how do we decide where we want to be on the cal? Well, we're going to use calculus. We're going to maximize the utility of investing in a combination of one risky and one risk-free. We're going to call this the combined portfolio C, and we're going to choose the optimal portfolio by maximizing the utility. We'll do this in a minute.